Hello everyone. Today let's solve the problem number 141, linked list cycle. So you can just go through the question and also you can just go through the example to understand the question better. So I'll just summarize the question so that it will be easier to understand. So what the question states here, we are given a linked list where our task is to determine if it contains a cycle or not. If it contains a cycle, then we have to return true, else we have to return false. That's what they have given here. A cycle in the linked list means that a node's next pointer connects back to an earlier node in the list. This is important. I'll just say this one again. Just listen to it. A cycle in the linked list means that a node's next pointer connects back to an earlier in the node. That's what they have shown in this figure as well. This forms a loop, and as a result, traversing the list will lead us into the infinite traversal unless we detect a cycle. You can clearly see here, right? So here the cycle is formed, so we are getting the output true, else we have to return false, right? So in example 1, this, if we consider here, the tail of the list connects back to the first node. This is 0 index, right? They have clearly mentioned this is 0 index. See here. So the tail of the list connects back to the first node. This forms a cycle, so the output will be true here. You can clearly see the output is true. For the second example here, the tail connects back to the 0th node, also forming a cycle. 0th node, here it is connecting to the 0th node, right? So it forms a cycle, so the output is true here. In the final example, there is no such connection at all. We have only one node, right? So there is no such connection at all. Hence the output is false here. The cycle is not for this one formed, so output will be false here, right? So that's what they have shown here. This is simple. So what shall we do first? So let's go with the approach as usual. Then let's discuss the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Let's start with the So let's discuss the approach one by one. Let's discuss the approach step by step here. So just give me a second here. So let's go with the approach. Just give me a second here. First thing is, we'll be making use of the Floyd cycle detection algorithm here. So I'll just give here Floyd's cycle detection algo here, right? Just keep this in mind. Also called as two-pointer technique. So we'll be going with the 2 pointers, right? Floyd cycle detection algo, or the two-pointer technique. So first, what we will do here, we will be making use of the 2 pointers. One is slow and one is fast, right? This is the first step. Then what we will do, we will be moving the slow 1 step at a time and fast 2 steps at a time. Slow, what we will do, 1 step at a time, and for fast, what we will do, we will move 2 steps at a time, right? This is what we'll be doing. So we are going with the slow and fast pointers. For slow, we are moving 1 step at a time, and this pointer, first pointer, will be moving 2 steps at a time. If there is cycle, if cycle is found, then slow and fast will eventually meet at some point, right? So if there is cycle found, then slow and fast, obviously they meet at some point in the this one. Eventually they meet at some point. Eventually meet at some point if cycle is found, right? This is one thing. And finally, the last step is, if there is no cycle, fast will reach the end of the linked list. If cycle is found, then slow and fast pointers will eventually meet at some point in the cycle. If there is no cycle, then fast will reach the end of the linked list, right? I'll just give here LL. So this is the approach that we are going with, right? Let's do one thing. Let's try to understand this one with the very simple example. So let's consider the first example that they have given in the question here. So example they have given here is, just give me a second here. Example they have given here is head, they have given 3, 2, 0, -4, and position they have given 1 here, and output is true because it forms a cycle at first index, right? So let's see this one step by step. Let's understand the input first. The linked list looks like this basically: 3, 2, 0, and finally -4 they have given here, right? So this one we can write this like this, is pointing to down here, forming a cycle basically. Position 1 means here position equals 1 they have given, right? Position 1 they have given here. So position 1 means that the tail node 4 connects to the node with value 2. This one connects with the node with the value 2. This forms a cycle. So they have got the output true. So let's see this one step by step. So initially what we will do, slow pointer points to the head of the list 3 here. Slow pointer points to the head of this one, head of the list, nothing but 3 here, points to 3, and fast pointer here points to the head of the list as well, nothing but 3 initially. This is initial step. Then we will start traversing, right? We'll make use of the 2-pointer technique. We know that by the approach, slow moves 1 step at a time and fast moves 2 steps at a time. When slow moves here, it will reach 2, and when fast moves here, it will reach 0. In example, you can clearly see here, slow moves 1 step at a time, fast moves 2 steps at a time, right? So here slow will be 2 and fast will be 0 here. So the state now slow will be 2 and fast is 0, right? So no cycle is detected yet. Slow is not equal to fast. Now at the first step, let's move to the second step here. Now what we will do, slow moves 1 step ahead, nothing but next step is 0, right? Slow will move from 3 to 0 here, second step. Now slow will be 3 here and fast will be this time fast moves 2 steps, right? So -4 and 2 due to the cycle here. -4, this one, and 2 again. Here it comes. So fast from here -4 and -2, it will be here, right? So fast will be here 2 due to the cycle. Now slow is 0 and fast is 2. Here also no cycle is detected yet. Slow is not equal to fast. Let's come to the third iteration. So third iteration will be slow moves 1 step ahead. Next thing is slow here 2. It was at 2. It moved to 0. Now the slow will be -4. It moves to -4, right? Slow will be -4 and fast will be fast moves 2 step, right? It was at 2. Now 2 steps will be 4 actually. It moves to -4 as well here. Slow and fast both will be at the -4. So the pointers meet. Now slow, if we compare, slow equals fast now, right? Slow equals fast, confirming a cycle exists here. Cycle exists. We can clearly see here, right? This is one thing. And finally we have to return the result. Since slow and fast met at the same node, -4, right? So we are returning the output will be true here. So this is how the algorithm works. So the final output will be true here, right? So this is how the algo works. We considered the example that has been given in the question. So we saw the example how we got the answer true, or how we got the output true. So let's discuss the edge cases one by one and then write the code and discuss the complexity of the code that we have read. So here let's discuss the edge cases one by one. Let's discuss the first edge case, nothing but for the empty list. So let's consider here head equals null initially. So the output will be false here. Head, we have the input head equals null. So the output will be false. Obviously, an empty list cannot have a cycle at all, right? So output will be false. This is for the empty list. And let's move on with the second edge case. This is for the single node, no cycle. When single node no cycle means, I'll just consider head 1, input to be 1, and position, let's consider here -1. So let me remove this braces. Position -1 here. So the output will be false here. Why the output will be false here? A single node without any loop cannot have a cycle at all. We know that a single node without any loop, we don't have any loop, we have a single node here. So single node without any loop cannot have a cycle. So the output will be false. This is for single node, no cycle here. This is fine. This is for the second edge case. So let's move on with the third edge case. Nothing but single node self cycle. Single node, well, while I say single node self cycle, head, let me give you input head 1 and position also, position -1 here. Sorry, position not -1, position 0, single node self cycle, right? So this will be true. We are having a loop at 1, right? So this will be true. A single node pointing to itself forms a cycle. We know that a single node pointing to itself forms a cycle, and the output will be true. This is for the single node self cycle condition. Let's go with the next edge case, multiple nodes no cycle. So here let me give multiple nodes no cycle. When I say multiple nodes no cycle, let me consider this one input head 1, 2, 3 and position here, let me give -1 here. 1, 2, 3 position -1, output will be false here. Why the output will be false here? The node do not connect back to any previous node here. Any, I mean the nodes, you can clearly check here. Any node, sorry, just give me a second here. Yeah, any node or the nodes do not connect back to the any previous node here. So output will be false here. Let's move on with the fifth edge case or the final edge case. Nothing but multiple nodes and cycle exists. Cycle exists, right? So here let's consider the input head here. Let me give 1, 2, 3, 4, 5 here. This is fine. Position, let's give here 2. The output will be true here. Why the output will be true here? Because the tail of the list connects back to the second node. Nothing but 0, 1, 2. This one. So the index will be this one. Position 2, index 2, this one. It connects at the tail of the node, connects back to the second node. 0th index, right? 0 index, right? This is 0, 1, 2, 3, 4 here. The tail of the node connects at the connects back to the second node. It forms a cycle. So at the position 2, it will be, the answer will be, or output will be true here. So these are the 5 edge cases that we need to consider. I hope all the edge cases are clear. First, we went with the empty list, and the second, we went with single node no cycle, and the third one, we went with a single node self cycle, and the fourth one, we went with multiple nodes no cycle, and the final one, we went with multiple nodes and the cycle exists here. So these are the 5 edge cases that we have to keep in mind. Let's next, let's write the code, and I'll explain the code while writing the code itself. And finally, let's discuss the complexities of the code that we have. Let's start writing the code here. First thing is, just give me a second here. Let's initialize the 2 pointers as we had discussed in the approach, right? Both starting from the head of the list. We can write here, let slow equals fast, both are pointing to the head, so we can write in this way as well. Slow equals fast equals head, or you can just consider slow equals head and fast let's fast equals head as well. Now let's traverse the list as long as fast and fast dot not fast dot next exist. So we can write in this way. Fast, let's consider fast and fast dot next here. And slow, we are moving this pointer one step at a time. This will be slow dot next. And what about fast? We are moving this one two steps at a time. This will be fast dot next dot next. This is fine. I hope this is clear. That's what we have discussed in the approach, right? Slow moves at one step at a time and fast moves at two steps at a time. So now we will check if slow and pointers meet. So this is one simple if condition. I just give here slow equals fast. If it meets, then we are returning true. So if the slow doesn't meet the pointer fast, then will return false because no cycle detected here. Here, if the cycle is detected, if slow and fast meets, then cycle is detected, we are returning true. If slow and fast doesn't meet, then cycle is not detected, then we will be returning false. Simple, right? So let me format this one once. Let's run the code here. So why this is time limit exceeded? So let's see what I have done. So what mistake I have done here is I have closed this one while loop, this one here itself. So we have to close this one here, right? So this one I had made mistake actually. Let me do one thing. Yeah. Now let me format this one once. Let me click the run button. So now you can clearly see the sample test cases are getting passed here. So let me hit the submit button. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity of the code that we have written. So the approach that we went with here is two-pointer technique or the Floyd cycle detection technique, right? So the overall time complexity would be here big O of n here. Why overall time complexity here would be big O of n? Because the slow pointer and the fast pointer traverse the list at most once. We know this one. Slow pointer and the fast pointer traverse the list at most once. So making this algorithm linear at a time. So the overall time complexity would be big O of n. So what would be the overall space complexity here? The space complexity here would be big O of 1. Why it is big O of 1? Because we are making use of the constant amount of extra space as no additional data structures are used. We are just making use of two pointers here, slow and fast, right? So that is the reason overall space complexity would be big O of 1 here. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.